chapter students. So till now we have completed 4 chapters. That is real number, then polynomial, then coordinate geometry, and lastly linear equation in 2 variables. So today, instead of going to the new chapter, let us revise the chapter 1. Let us revise the chapter 1, and before revising, let's see what you have studied there. Actually, basically we have studied there that what is real number, how to represent a number on a number line, then to find the numbers in between two real numbers, then under what condition a number will be rational and irrational. Then we have seen how to represent a irrational number on a number line. Then also we have seen to represent fractional irrational number on a number line. And then finally we have studied the laws of indices. So what are the things? First I told that number line. This is the number line. Number line we have studied. And to represent, suppose 1 by 2 on a number line. And on the number line, you know, as you go towards your right, the number will go on increasing. And if you go to your left, that number will go on decreasing. And 0 is a number which has no sign, neither positive nor negative. Right of 0 is a positive number, left of 0 is a negative number. Okay? So let us represent this 1 by 2 on a number line, and then first of all you convert into that improper fraction. How many types of fraction? There are 3 types of fraction: proper fraction, improper fraction, and mixed fraction. And this is the mixed fraction. So from mixed fraction we'll convert into improper fraction. So what is that? 3 by 2. Now you take the scale and take the equal space, maybe 1 centimeter gap. After each 1 centimeter give 1. So that is 1, then 2, then 3, so like that. So let's see, suppose this is 1, this is 2, this is 3, and so on. So here what you will do, instead of giving 1, suppose I am taking 1 centimeter as half. 1 centimeter represents half. Then 2 centimeter will represent 2 by 2, and 3 centimeter will represent 3 by 2. So this is your representation of this one. Okay? So this is the one. The next, you see, next what you have studied, that to find the rational numbers between 2 rational numbers. Suppose 1 by 2 and 1 by 3. So what you have done, first of all you have equalized the base, that is denominator. Equalize the denominator. So what is the LCM of 2 and 3? LCM of 2 and 3 is 6. So ultimately it will be 1 into 3, then 2 into 3 equal to 1 into 2, then 3 into 2, then ultimately what is that? That is 3 by 6, and then 2 by 6. Okay? Well, 3 by 6. Now, suppose if I ask you that find 5 rational numbers between 1 by 2 and 1 by 3, then how can you take out exactly 5 numbers? Exactly 5 numbers. That, see, first of all you have to equalize. So we have equalized. Then you have to see the difference of the numerator. So what is the difference of the numerator? That 3 minus 2. 3 minus 2 is what? 1. So if the difference of the numerator after equalizing is 1 and required number is 5, then 1 more than the required number. 1 more than the required number, you have to multiply both numerator and denominator. That means I need 5. How much I have to multiply? Because the difference is 1, I have to multiply 6. Both numerator and denominator, I have to multiply 6. If it will be 3, how many you have to multiply? 1 more than the required number, so it will be 4. If you have to get 10 rational numbers between 1 by 2 and 1 by 3, then what you have to do? 1 more than the required number, and this one difference is 1, numerator difference is 1. Then 1 more than the required number is 10. So 1 more than 10 is then even you have to multiply. So let us see which one. So suppose I need 5 rational numbers between 1 by 2 and 1 by 3. So then what we have to do? See 6, 6, 6, 6. So then it is 18 by 36, and here it is 12 by 36. Now you count 13, 14, 15, 16, 17. 13, 14, 15, 16, 17. And in between these two, in between 18 and 12. So ultimately what are the required numbers? Required numbers are 14 by 36, 15 by before that 13 will come, 13 by 36, 14 by 36, 15 by 36, 16 by 36, and 17 by 36. So these are the, so see, exactly 5 numbers will be there. Now some of you may think, if it is if difference is 2, then what do you have to do? If difference is 2, then you have to divide the required number. If difference is 2 or 3 or 4, whatever it may be, other than 1. If 1, then remember exactly that 1 more than the required number. But other than 1, then you have to divide the required number by the difference. Divide the required number by the difference. That means, suppose it is 2, then what you have to do? Required number is 5. So what you will do? See, 5 you have to divide by 2. So 2, 4, 1. So it is a fraction. Fraction we cannot multiply. So next round figure. What is the next round figure? Next round figure is 3. So you have to multiply both numerator and denominator by 3. That means that fraction will be converted into round figure, and we have to multiply. But remember one thing, if difference is 1, exact number you get. But if difference is other than 1, then you may not get exactly, but it will be more accurate than any other method. Okay? So this is the thing you got. Then you have got that how to represent irrational number on a number line. That is irrational number on a number line. And that is suppose root 3 or root 5. Okay? So this those things you got root 2, then root 3, and so on. And also we have seen that 7.5, then suppose 3.7, and total. This thing also you have represent on number line. Okay? So here you have to remember one thing. If this thing will come, it may be for 2 marks. It may be for 2 marks. But if this type of question will come, it will be of 3 or 4 marks. It may be of 4 marks also. Okay. So that one, when I have done the chapter, I told you how to do. First, so see, First of all, you have to draw a right angle triangle. Isosceles right angle triangle. If it is root 2. Suppose isosceles right angle triangle. I will show both side by side so that you can understand the difference. See, here suppose O, this is A, this is B. And here, this is an isosceles right angle triangle. This one equal to this. OA equal to AB equal to 1 cell. Say 1 unit. 1 unit. Okay? Whether you have taken 2 centimeter, y equal to 2 centimeter or 3 centimeter, forget about that. It depends on you how, because bigger you take, it will be looking nice. Or to draw the arc, it will be easy for you. If you take small, then it will be a problem for you to draw the arc. So that's why you can take 2 centimeter, OA equal to 2 centimeter, and AB also equal to 2 centimeter or 3 centimeter. But ultimately, we will consider that that is 1 unit. Okay? Then what? Then as it is a right angle triangle, so which theorem we will use? We will use Pythagoras theorem. Okay? So Pythagoras theorem, according to Pythagoras theorem, OB square equal to OA square plus AB square, and then OB square, OB equal to root over 1 square plus 1 square equal to root 2. That means OB is your root 2. Then what you have to do? Then you have to take the length OB as your radius. OB as your radius and draw the circle. OB as your radius, take your compass, take O as center and OB as radius, draw the circle. Circle means what? As you start from here, O as center, OB as radius, the moment you will take, it will come and cut the line at a point, still that much, not to complete the whole circle. But process is this, that O will be the center, OB will be the radius, and draw the arc. And then what will happen? That this will be suppose A1. Then that OB will convert into OA1, which is equal to root 2. That means you can see one thing. See, this is the part you have taken. And this part, when you are coming, it is joining this part. So the moment you are rotating in clockwise direction, it will come and join your horizontal line. And the point where it will cut the horizontal line or meet the horizontal line, that is the length of the radius. Okay? That is the length of the radius. So this is one. Then let's see the other one, that is this one. This one, what is the difference? See, here it is a little bit different first of all, but afterwards, suppose this is OA. And here OA equal to suppose 7.5. OA equal to 7.5. Then you have to take one more unit. Suppose this is B. Then what is the length of OB? OB equal to OA plus AB. And AB, how much I told? AB is 1. 7.5 plus 1 equal to 8.5. Equal to 8.5. So OB is the total length is 8.5. Now what do you have to do? You have to draw the perpendicular bisector. That means you have to get the midpoint of OB. You have to get the midpoint of OB. So midpoint of OB, you know the perpendicular bisector. You have learned in earlier classes, and in when I have done this chapter, that time also I told you how to draw that perpendicular bisector. Now, if some of you think that drawing perpendicular bisector you need some more time, it will be time consuming, then you can avoid that. How to avoid that? How to avoid that? you best thing is that suppose physically, that means actually OA is your 7.5 because that is the value given. But you can, by scale, you can take OB as 3 centimeter. OA is 3 centimeter and AB as 1 centimeter. Then 3 plus 1 how much? 4. Then what will be the midpoint? Then very easily you put the scale and you can take out your midpoint. So suppose midpoint is here. Midpoint is here. Clear? Midpoint is here, and then you draw a semicircle taking suppose this is C, taking C as center and OC as the radius. Draw a semicircle taking C as a center and OC is the radius. Remember, OC and CB are of equal length. OC and CB are of equal length. So then you draw. For this purpose, I have to draw this part. Okay, I have to draw this part. So then take your compass, take C as center, OC is the radius, and draw the semicircle. Draw the semicircle. We have drawn the semicircle. Then what you have to do? Then at A you have to draw perpendicular. At A you have to draw perpendicular. Now, do you remember how to draw perpendicular? You take your protector. You take your protector and put at A and draw the line. Take the point. Suppose this is the point and join this point. You will get the perpendicular. So this is the perpendicular we got. And then you join. Suppose this is your G. Then join CG. This is the figure for that fractional number under the radical sign. And this is the figure, the whole number under the radical sign. Now what is the difference you see? Here also you are getting the right angle, but here beginning you are getting the right angle triangle. Here after drawing all this, then you are getting right angle triangle. And what are the difference? You see, we have written that OB equal to 8.5, then OC equal to CB equal to OB by 2. That means what? That means it is 8.5 by 2. Okay? 8.5 by 2. Now, so that means OCCB. What is the relation of CG? CG is also radius. CG is also radius. Then what is the value of CG? CG is also same. CG is also same. CG is also equal to 8.5 by 2. Got it? Okay. Now next you see. Here what you have to do, then we have to take out that we got CG, we have to get that CA. How to get CA? CA will do by this. CA equal to, you see, CB minus AB. CB equal to how much? 8.5 by 2. And what is AB? AB is 1. So ultimately what is that? 6.5 by 2. 6.5 by 2. Now, in the last case, if you see, we got the base, we got the altitude, we did not get the hypotenuse. But in this case, we got the base, that is CA, we got the altitude. We got the base, we got the hypotenuse, we did not get altitude. So here we have to calculate altitude. Here we have to calculate altitude. Clear? So remember, for this that number to represent on the number line, that is under the radical sign, fractional number under the radical sign, this calculation is the most important. This calculation you have to do. This is the most important calculation and best way to take out the midpoint and all. That whatever matrix, suppose it is 3.7, then also you can take that OA equal to 3.7, AB equal to 1. And for your construction, you can take OA equal to 3, AB equal to 1. Then it will be very easily you can take out the midpoint. Clear? And after that, what you have to do, after that you have to use your this right angle Pythagoras theorem. So according to the Pythagoras theorem, you see that CA square plus AG square equal to CG square. Now, which is missing? CG is given, CA is given, AG is missing. So AG square equal to CG is how much? CG is 8.5 by 2. 8.5 by 2. 8.5 by 2. And what is CA? CA is 6.5 by 2 whole square. Then you take out the AG equal to root over. Now here, instead of taking out the square, what we will do, we'll use a square minus b square formula, then it will be easier. How? You see. Because if you do the square, then it will take time. But if you do a square minus b square formula, that is, what is that? A square minus b square equal to a plus b, a minus b. Then what it will be? It will be, you see, 8.5 by 2 whole square minus 6.5 by 2 whole square. Ultimately, 8.5 plus by 2 plus 6.5 by 2, and then 8.5 by 2 minus 6.5 by 2. Then what is that? Ultimately it will be, so 8 plus 6, 14, 14, 15, 15 by 2 into 2 by 2. So ultimately how much? 7.5. And we need 7.5, okay? So that one. So under that, 7.5. So you got? So last one, we have drawn the arc by taking the measurement of OB, but here we'll draw the arc by taking the measurement of AG. Last one, hypotenuse, here altitude. Last one, if under the radical sign a whole number, it will be hypotenuse, and if it is a fractional number under the radical sign, then altitude you have to take and you have to draw the arc. So here you see we got AG. AG is how much? 7.5. So take AG, A as center and measurement as AG and draw the arc by the compass. Okay? Then this is your B. This is suppose B1. This is your B1. Okay? This is your B1. So then, what is the length? What is the length? AB1. AB1 is your root over 7.5. AB1 equal to 7.5. Okay? So ideally, you see, OB here, this one, same process is same. See, this one you just rotate and then it will match. Clear? This one will work. And then another important part you got, that is the laws of indices. And that laws of indices, I'll just show that the formally, and then in my next class once again the same chapter I'll revise, same chapter I revise. Now for a few days I'll revise all the chapter so that whatever confusion you have, whatever part you are not able to understand, you can grab it again. So that's the reason. Okay. So the laws of indices today I'm giving, and next class I'll discuss about its application. Okay. So what was that? That a to the power m into b to the power m equal to a to the power m plus sorry, this is n, suppose this is a to the power m plus n, then a to the power m divide a to the power n equal to a to the power m minus n. Then suppose a to the power m whole to the power n equal to a to the power mn. Then a by b whole to the power n equal to a to the power n, b to the power n. Then a to the power 0 equal to 1. And then fractional part a to the power minus n equal to 1 by a to the power n. So these are the formulae for laws of indices, and in my next class I'll discuss about the application of that. So my dear student, please revise that whatever I have done today, please revise once again, and then it will be easy for you. Okay, till that time, thank you.